We could do it if it was set equal to other stuff. I just don't think that's necessarily what we need right now. So then sine A is equal to 0, and 2 cosine A plus 1 is equal to 0. And those turn into nice questions from 7.3 that way. So we'd have what A is 0 and anything coterminal to 0, or A is what, pi and anything coterminal to pi, which means actually we could combine those into 0 plus k pi. And then cosine A equal to -1/2. You guys remember how to do these. A equals, what's the cosine inverse of -1/2? That's what, pi over 3 plus anything coterminal. But of course, that's also going to have pi over 3. How about 2 pi over 3? Sorry. Of course, it's also going to happen at 4 pi over 3 down in quadrant 3, and anything coterminal to that. So we get those solutions using that nice double angle formula to expand that sign and give us some manipulation power. Questions about that example while I've got you here? I know I went through it kind of fast, but so, like with our sum and difference formulas, we'll often see these from the perspective of given some ratios. So I'm going to have you try one of those and see how far we get. So how about given that the sine of theta is equal to 2/3 in quadrant, let's say 2, and the cosine of phi is equal to, let's say 3, how about 4ths? In quadrant 4, find, we can now look at more types of combinations. We could still look at, say, the sine of theta minus phi, but now we can also look at things like the sine of, doesn't matter which, 2 theta, and the cosine of, say, 2, let's go with phi. So find those 3 values real quick, and we'll see how everyone's doing. I am getting a little nervous about how quiet it is around here. So find those, write them down, hold on to them, don't put them up so we can compare. But do take a moment and do this. I think I'm going to have to put a quiz up to make sure everybody's doing okay. I'm starting to worry. Yeah. You have a test on Friday, so a quiz due Wednesday is probably a good idea. Yeah, quiz Wednesday. Yeah, quizzes are good. They allow us to kind of communicate with each other, make sure we all know where we are. Quizzes are helpful. So I'll give you until 1:20. It's 4 more minutes. Dominic, exact values. Always exact values with these. Excuse me. So those triangles are kind of our preliminary work. We got to set those out first so we can find the sine, cosine, or tangent, whatever we want of any of those, or any of the trig functions for either of those angles. But what do we know that sine of a difference is equal to? Well, our angle sum and difference formula for sine up here tells us the sine of a difference is the sine of the first times the cosine of the second minus the sine of the second one times the cosine of the first one. So the sine of theta, we were actually told, is 2/3. Heck, even the cosine of phi, we were told, 3/4. Minus sine of, sine of phi, well, got to go over to phi. The sine of phi is going to be negative square root of 7/4. So negative square root of 7/4 times the cosine of theta, and the cosine of theta would be negative square root of 5/3. Questions about where any of that came from? Then we just got to put that all together. So 6 minus the square root of 35 all over 12. And I suppose if you wanted to, you could turn that into 1/2 minus the square root of 35 over 12. But I don't think that's better. Either one would be fine. But don't do the division with the 6 and the 12 and leave out the 35. That would be the bad thing to do. Now, if we wanted to compare that to Dominic's decimal approximation 0.007, 0.007 was quite small, but 6 minus the square root of 35, that should be quite small. Square root of 36 would be 6. So 6 minus square root of 35 is quite small. Divided by 12, that 0.007 sounds pretty reasonable. For the sine of 2 theta. Now, before we figure out what the sine of 2 theta is, I do want to mention something. We know theta is an angle in quadrant 2. That means theta is somewhere between pi over 2 and pi, right? We know theta is between pi over 2 and pi. So if we want 2 theta, if we're finding 2 theta, that should be somewhere between double everything, somewhere between pi and 2 pi. So the double theta is going to be somewhere down here. So we should expect this value to be negative. Now, did we have to determine that? No, but I like to kind of keep these things in mind, particularly when we get to half angles and it becomes important. But what do we know about the sine of 2 theta? Well, from our double angle formula for sine, we know sine 2 theta is equal to 2 times the sine of theta times the cosine of theta. 2 times the sine of theta, well, we were told the sine of theta is 2/3. The cosine of theta is the negative square root of 5/3. There's where the negative comes from. So we're going to get to what? Negative 4 square root of 5 over 9. Give me a thumbs up or a yeehaw or a hoo-ah or a Shay. You good with that? Dominic? Yeah. Yeehaw from Dominic. Nice. Sam, Nick, Nicholas, Martin, Garrett. Garrett, good. Nick, good. Martin, yeehaw. Love the enthusiasm. Nicholas, if it's not okay, let me know. If it is, great. You might be storing up a question there. Now, cosine 2 phi, we have options. We could grab the kind of primary basic double angle formula for cosine. We could grab that, use that, wouldn't be a problem. Let's actually just do that. That would be the cosine squared phi minus the sine squared phi. So the cosine of phi, what was the cosine of phi? We were told that it's 3/4 squared minus the sine squared. Well, the sine for phi was what? Negative the square root of 7/4, which is ugly, except we're going to square it. So won't be a problem. So 9/16 minus what? 7/16. So 2/16 or 1/8. Great, done. However, since we were given the cosine of phi, it wouldn't be unreasonable for us to have grabbed the version of the double angle formula for cosine that only involves cosine. So 2 times that cosine squared of phi, oops, no parentheses there, sorry, minus 1 should also work. And it's using just the given information, so that's nice. It would have saved us this calculation if we hadn't had to have done it anyway. So that would be what? 2 times the 3/4 squared minus 1. So 2 times what? 9/16 minus 1. So 18/16 minus 1, which is 16/16, is 2/16, which is the same 1/8. So it still works. It better still work, or we're just making stuff up here, right? Heck, if we really wanted to, if we were really in that kind of mood, we could have done it with just the sine version, just this one. 1 minus 2 times the negative square root of 7/4 squared. So just using the sine version. Same thing would have happened. 1 minus 2 times 7/16 It's 1 minus 14 sixteenths is 16 sixteenths minus 14 sixteenths is 2 sixteenths is the same 1/8. It's never going to be able to avoid it. Now, this isn't even the best reason for having 3 different versions of the cosine double angle formula, but it is nice to have choices. You can use the tool that uses as much given information as possible. Questions about any of these? All right. Well, then if we're happy, I want to look at those 2 forms, that cosine 2 theta 1 minus 2 sine squared theta and cosine 2 theta equaling 2 cosine squared theta minus 1. I got that order right? Yeah. Because the fact that we can write these in these 2 ways actually gives us another set of tools that we can build. Actually, frankly, 2 sets of tools that we can build. And the reason for that is, unlike most of the other sum and difference formulas that ended up having both sine and cosine in them, sine and cosine in them, sine and cosine in them, other than tangent, and even tangent has tangent A and tangent B, which means they don't want to communicate very well. Both of these, one trig function is turning into one trig function. Okay, it's squared, be multiplied by 2, but still, that's kind of unique in all of these manipulations. And that gives us something that we can do. We can manipulate both of these by solving for that trig function. So in this cosine version, I'm going to solve, well, this cosine double angle, this version, I want to solve for that sine theta. And that's actually going to build us a couple tools. How are we going to do that? Well, the normal way we solve. Going to subtract the 1 from both sides. Cosine 2 theta minus 1 equals -2 sine squared theta. Divide by -2, divide by -2. I'm going to take that negative and use it to switch the order of that subtraction. Divided by 2. Hopefully that doesn't bother anybody too much. Sine squared theta. And if we stopped here, this is actually a huge tool. It's called the power reduction formula for sine. Sometimes squaring is a problem, particularly for those of you going on to calculus. When you do, and anything based on calculus, when you do integration with the sine and cosine functions, those squares are irritating. They're in the way, they're a problem. So often we will use this power reduction formula to get the squares out of our trig functions. Now the price we pay is the 1, the divided by 2, and especially that 2 theta in there. So there is a price to pay for this manipulation, but it can be very handy. Now we're not going to stop there. We're going to keep going and solve all the way for that sine theta. And we're going to do that just by taking that square root. We do get the plus or minus. When we take the square root, we'll have to deal with that. 1 minus cosine 2 theta all over 2. So that gives us this formula solved for sine. Now, why this is helpful? It's helpful, like a lot of our other tools. It gives us a way to go from, well, this looks like it's a way to go from a 2 theta to a theta, a double angle to an angle. But with just a little change in notation, if we let, say, A equal 2 theta, then A over 2 equals theta, and we can turn this double angle formula that we started with into a half angle formula. If I perform those substitutions, then the sine of A over 2, the sine of half an angle, is either plus or minus the square root of 1 minus the cosine of the angle A over 2. So that becomes our half angle formula for sine. You want a quick example of how we would use that? Let's say we want to know the sine of, oh, let's go nice. Let's go 15 degrees. We haven't done degrees in a while. Well, I don't know what the sine of 15 degrees is. I can ask the calculator. It'll give me an approximation. But we can find this exactly because we know the sine of 30 degrees. And 15 is half of 30. You might remember we could also do this with 45 minus 30 using our sum and difference formulas, but we're going to do it this time with the half angle formula. Since 15 is half of 30, these two things are equal. And we know this is equal to either the plus or minus, we will have to pick one, of the square root of, down there, 1 minus the cosine of 30 degrees over 2. So the square root of 1 minus, what's the cosine of 30 degrees? It's the square root of 3 over 2, all over 2. Want to clean that up, so I'm going to multiply top and bottom of that by 2. Get the, I don't know why that's such an angle. Give us the square root of 2 minus the square root of 3 when that 2 distributes. Multiplied by 2 to clear out that 2 in the denominator. Over 4. So the square root of 2 minus the square root of 3 over the square root of 4 is 2. Now, which do we want to use, a plus or a minus here? We can't leave them both on there. And so we have to pick one because this is a function. But we know what quadrant 15 is in. 15 degrees is in quadrant 1. Sine in quadrant 1 is positive, so positive all the way down. So boom, half angle formula. We could even back up if we wanted to this problem up here. Can't quite see the top of that and the bottom of that at the same time. But if we look at this problem with the sine of theta was 2/3 and the cosine of phi was 3/4, if somebody came and put in a 1.5 here, where they wanted us to find the sine of, let's say, which one do I want this one? Half of phi divided by 2. Well, plus or minus, and again, we can't leave the plus or minus. We have to choose one of those. So plus or minus the square root of 1 minus the cosine of phi over 2. So I'll let you decide whether it should be plus or minus. I'm going to leave it there for a minute, but we have to choose. The square root of 1 minus cosine of phi is 3/4. So 3/4 over 2. And then we'll clean that up. Clean it up the same way we did the other one. Multiply by 4 to get rid of that denominator. So the square root of 4 minus 3 over 8. Again, still going to let you guys decide on that plus or minus. So how about either plus or minus the square root of 1/8, which you'd of course clean up into what, the square root of 2 over 4? Let me do that out. 1 over the square root of 8, which is 2 square root of 2. So multiply by the square root of 2, multiply by the square root of 2. And yeah, square root of 2 over 4. Okay. But plus or minus. So going to give you a minute, ask questions about that. There was a lot of little manipulation in there. So ask questions about that and or suggest whether it should be positive or negative. Again, we have to choose one. It's a function. We're only allowed one answer. So should the sign of half of phi be positive or should it be negative? And or have you got any questions in there? You know, really, it's just a new formula, so you plug things into it. But so I'm looking for either a question or a plus or a minus, and I'm looking for 7 of them. I will also accept I have no idea whatsoever. I will accept I have no idea. It's a good life lesson. Never be afraid to say, I don't know. You know how many people get in trouble because they don't say, I don't know? If a fire started, would you know how to put it out? Sure. If you don't know, people die. That was weird. So that's 1. There's 6 more. Dominic said positive. Did you find the cosine inverse for the angle and then evaluate half of that angle to get a decimal approximation of it? I was curious if that's how you did it. Yeah, yeah. That works, but it just is, do you know why? So I respect the ingenuity, but you started messing with the calculator. I'm like, oh, he's just numerically that thing. So yeah, Shay, we're still trying to see if we know whether it's positive or negative. It isn't given. It's implied. There's not any actual work really that we have to do to find it or to know whether it's positive or negative. Not really. So see, of the 7, I've got a quadrant 4, quadrant 2 argument, and I don't remember and I don't know. There's still like 4 of you, 5 of you, 3 of you. I can't do math today. Why are you guys being so quiet? Shay says positive. If nothing else, just say something so I'll move on, right? I don't know is a fine answer. But I like Dominic's reasoning. We knew that phi was in quadrant 4. So that means phi is between 2 pi and 3 pi over 2. So we know phi is down in here in that quadrant. Just about everything we ever know about positive or negative is going to be an argument about quadrants. Where are they? So if we're looking at half of an angle, and that angle is between, if you want, it's between 360 and 270, that means half of that angle has to be between 3 pi over 4 and pi, or in degrees if you want, between 180 and 135 degrees. So it's somewhere in here. So half of phi, as Dominic said, absolutely, half of phi has to be in quadrant 2. Not just in quadrant 2, but in the second half of quadrant 2. Not that matters for our particular question, but we know it's in quadrant 2. What is the sign of an angle in quadrant 2? Well, sign of an angle in quadrant 2 is definitely positive. So positive all the way down. Positive, 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 positive. Anytime you're trying to figure out whether something is positive or negative, it's always a quadrant argument. The one thing that often happens with these positives or negatives is people look at the given angle. So we look at, okay, this is a problem about phi. We're using the cosine of phi here, and that's in quadrant 4. So often people will put this as negative because they think, hey, this problem is happening in quadrant 4. But it's not happening in quadrant 4. It's happening at half of quadrant 4. This problem is occurring in quadrant 2. We're just using a quadrant 4 answer to find it. So yeah, is it given? Not always directly, but since we're told where phi is, we know where half of phi has to be. So that is the one thing that makes these half-angle formulas a little bit on the sticky side. Now that's just the half-angle formula for sine. For cosine, though, we do exactly the same process. Add the 1, get 1 plus the cosine of 2 theta equals 2 cosine squared theta. 1 plus the cosine of 2 theta divided by 2 equals cosine squared theta. Take a moment to recognize that, hey, this is a power reduction formula for cosine, which will be extremely powerful later on in your mathematical careers. Frankly, for the most part, you use this form a lot more than you use this form. We just don't have anything to do with it right now because we don't have those calculus tools. Once you have those calculus tools, this is the big tool. But the other one does come up every now and again. Cosine theta, once we take the square root of both sides, still has a plus or minus. 1 plus cosine 2 theta over 2. It is weird, I think, that both the half-angle formula for sine and cosine both have cosine in them, but that's, again, because they both come from the double angle formula. Do the same substitution we did down here, and we get that the cosine of half an angle is equal to plus or minus, depending on the quadrant we're in, the square root of 1 plus the cosine of A over 2. So that builds us sine and cosine's half-angle formula. Just so we can see it used, let's say we have the cosine of, what do I want here? What do I want here? How about 11 pi over 8? If you tried to use the sum and difference formulas to find two angles that add or subtract to 11 pi over 8, you would be looking for a long time. It really wouldn't be effective. However, if we recognize that eighths are half of fourths, 11 pi over 4 divided by 2, 11 pi over 4 divided by 2 is 11 pi over 8. And we know about 11 pi over 4. 11 pi over 4 is one of our standard angles. So that allows us to turn this into plus or minus. Again, we have to pick one of those. We can't just leave that there. Plus or minus the square root of 1 plus the cosine of that known angle, 11 pi over 2, all divided by 2. Now, I want to decide whether it should be plus or minus before moving on, just because really we can't write that plus or minus all the way down or they're not equal. So again, I'm going to have you guys take a minute and decide whether that should be positive or negative. I'll give you 1 minute or less. Should that be positive or negative? Sorry, this should say 11 pi over 4. Shay, did you say negative, or was that the other problem? Samuel saying positive. Which angle are you looking at? Do we care where the 11 pi over 4 is, or do we care where the 11 pi over 8 is? Which one are we trying to find the cosine of? Are we trying to find the cosine of 11 pi over 8, or are we trying to find the cosine of 11 pi over 4? I don't know about you. I'm trying to find the cosine of 11 pi over 8. So what matters is what quadrant is 11 pi over 8 in? 11 pi over 8, well, 8 pi over 8 is there. 16 pi over 8 is there. So what's halfway between those? Is what, 12 pi over 8? So 11 pi over 8 is got to be down in quadrant 3. Is that fair? Yeah. 11 eighths is more than 1, so it's more than 1 pi, so it's got to be more than 180 degrees, so it can't be in quadrant 2. It's a little bit hard to tell whether it's in 2 or 4, sorry, in 3 or 4, but it is smack dab in 3 if we look at the possibilities. So what's cosine in quadrant 3? Cosine in quadrant 3 is negative. That does take practice. But past that, we can certainly determine 11 pi over 4. 11 pi over 4, what's 11 pi over 4? All the way around would be 8 pi over 4, 9 pi over 4, 10 pi over 4, 11 pi over 4. That, Garrett's in quadrant 2. The 11 pi over 4 is in quadrant 2. Cool. So the 11 pi over 4 is in quadrant 2, which still makes it negative. So negative the square root of 2 over 2 divided by 2. And again, we're going to multiply by this denominator to clean it up. That denominator is often, but not always, a 2, so be careful about that. Multiply by 2, square root of 2 minus the square root of 2 over 4. This happens a lot, but again, only with our standard angles. It didn't happen, notice, with the problem up here. We had to multiply by 4 because that denominator was 4, so the pattern was a little bit different. But we end up with negative square root of 2 minus the square root of 2 all over 2. A lot of twos in that problem. So these do take practice. We will get practice with these. But again, notice how we're having to keep track of that. What quadrant am I in? What angle am I looking at? That same stuff that we've been having to keep track of the whole time. It's just starting to, get a little bit more convoluted. So we got to be careful with it. Go practice, go practice, go practice. Take a short course on shyness in small groups to work on that. I'm sure there are many, like YouTube videos and things on getting over shyness on Zoom chats. If you think I'm going to stop picking on you about it, you do not know me very well. Shay knows. I will post a quiz later today that will be due on Wednesday. So that'll give us a chance to practice some of this stuff, make sure we're all okay. I'd have it due tomorrow, but there's a lot of people who aren't here, so I want to make sure they have a chance. So we'll have that quiz due Wednesday. We do have a test on Friday. We're going to practice this stuff in, vicious ways over the next couple days, and hopefully we'll get comfortable with that. Anything you guys need before I drop you out? Okay. Go forth and have a wonderful day.